So looking at our web page here on Blackboard, courses, this semester, Tuesday, Thursday, and there's the project. There's two pieces to the project, the actual project, and then the rubric, how I'm grading you. So you want to make sure that you do everything in the rubric. Some of it is silly, like I asked for a uniform paper. If you're going to send it to me electronically, no uniform paper, right? If you're sending it to me electronically, you don't have to staple it. So there's little things on there that I want. Who are my computer programmers in here? Nice. So if you want, you can, instead of doing this on Excel, like I'm going to show everybody, you can do it in Java, C++, you could do it in Python, I don't care. Okay? So it's just telling you all the things I'm looking for, right? Group names listed. So you can work up to with 3 students total. Okay? 3 students total. You can work with only 1 other student, so 2 total, or you can do it by yourself, you anti-social, right? But I understand that, sometimes it's hard to get together with people to work on it, but I don't think it should take more than 4 hours to do it. So, an hour investment here and there, a little bit of individual work, right? Should take care of it. There's computers. There's a computer room. No, there's no computer room. There used to be a computer room above the Math Learning Center. Yeah, but the Math Learning Center, you can use computers. There's a bunch of computer rooms, right? Like the 3rd floor of the Student Center, right? So anyway, there's the rubric. The project itself was not written by me. I stole it. I think somebody at Rice University or something like that. But you can find the answers. I'm asking for a little bit more than their answers. So if you found the answers, make sure you still read the rubric and make sure you give me the answers I want, right? So it reads like a super nerd, okay? So it reads way more complicated than it actually is. So read it. Make sure you watch a video on Newton's method. Make sure you look at the section in the book. I think it's 4-7, whatever it is, right? So there's a bunch of parts. The first part is not till part A. I'm pretty much going to do part A for you. And then part B is just renaming the answer you got from part A. So, and then part C is the first time you're actually doing the project. So what's actually happening here is Newton said, you know what? I want to find, oops. This is when I have too many things open and then my memory starts to lag. Close the calculator, close Excel, draw my curve again. Oh, there it is. So Newton said, hey, I want to find, let me do a different one. I want to find this 0, right? I want to find the root. Again, it's about zeros again. All the way back to algebra 1, right? So Newton says, well, if I guess and I hit it, perfect, right? So let me guess. Let me guess that this is my root. So we're going to call this guy x sub 0. X sub 0 is the initial guess. And then I'm going to go up to the curve and draw the tangent line. And guess what? Do you see that it hits close to the zero? So that's my next guess. So where the tangent line hits the axis, Newton realized he's going to get closer and closer. Sir Isaac Newton, right? Came up with this. Going to get closer and closer until eventually finding the root. So, and this is what your calculator is doing. When you press square root of 2 on your calculator and tell it 8 decimal places, it's running through this computer program that I'm about to show you until it gets to 8 decimal places. So you can see we got a tangent line, and our next guess is coming from where the x hits the axis, right? So this is my tangent line in green, yes? And then what do you want to call this point here? What are you thinking? What should we call that point? X1, comma, what? 0. So we know the y value there is 0, right? So think about my tangent line. Anybody got the equation of my tangent line for me? Nice. Y minus y1 equals m times x minus x1. Nice. I'm going to change my notation a little bit because you can kind of see I'm using x sub zeros, right? So I want to call this guy here, right? I just have to think for a second. But I also want to change my slope. What's my slope going to become? So I really want to go y minus f of x sub 1 equals f prime of x sub 1 times x minus x sub 1. Right? I want to use my my notation. So the real question is my initial guess was x sub 0. My initial height for that x sub 0 was f of x sub 0. So I want to use that instead of x sub 1. So y minus f of x sub 0 equals f prime of x sub 0 times x minus x sub 0. And I want to remember, so I know everything about this except for what two variables here? What are the two variables that are still variables? At y and x. But that's where my line hits. So meaning my line, my y is going to be 0, and my answer is going to be, right, my answer for my next guess, I'm going to call that x sub 1, right? You with me there? I'm going to call it x next, is what I like to call it. So I'm solving for what? X next. I'm solving for x next, because that's what I want to put back in my machine, right? So these are called iterations. These are called iterations. I get an answer out of the machine. I take the answer, put it back in the machine, right? I take a guess, see where the tangent line hits, take that new guess, put it back in, get another tangent line, get a new guess, keep doing that. That's what Excel is going to do for us, or that's what you're going to do with what languages you guys are using. What do you like? C++, sure. Right? So programmers can use any language you want here. I'm going to teach everybody else how to do it with Excel. So let's solve this for x sub next. I could distribute or I could divide. What do you like? Good, I like it too. I like x sub next minus that initial guess, x sub 0, is negative f of x sub 0 divided by f prime of x sub 0. So you can see already I'm putting my initial guess in the function and in the derivative, right? And so final answer for x sub next is just move that x sub 0 over. And so that's kind of wordy or notation nerdy. So I'll just change my x sub 0 to x. And there it is. There's your answer for A and B. Part A and part B done. Right? You'll need to make it pretty and write in some English and all of that, but of the project. Is part A, B, C, D, E, F. A and B are easy. It doesn't read easy, but they are. Part C is you're actually going to be doing the iterations. Part D, actually doing the iterations. Part E will stay abstract. Keep it algebraic, no numbers. Part F, 3 different times when Newton's method fails. If you're working alone, do only one of them. If you're working with 2 people, do 2 of them. If you're working with 3 people, do all 3 of them. Right? Split them up. Split those, divide and conquer on those, right? Real quick, let's take a look at something called GeoGebra. Some stupid name for geometry, GeoGebra and algebra. I hate the name, but it's pretty cool. So, and I go Newton's method. So there's my initial guess. They use x sub 1, whatever, it doesn't matter. If you look at my formula, it's just an x now, right? And the what I get out is the next x, right? So I show that first tangent line. Hello. Oh, there it is. And it shows me where it hits the x-axis. That's my x next, right? Is that making sense? I go up to the curve, draw another tangent line, repeat the process, and do you see my tangent lines are hitting closer and closer to the actual root, right? So that's the process. Nice. So in part C, it's the first time we're going to use this process. You're going to see me do it on Excel. Okay? I am recording this, so you can go back and watch it. It says 1 over x equals 1 plus x cubed has one positive solution. Let's find it, right? 1 over x. So I'm going to Desmos. I'm going to graph that y equals 1 over x. And the 1 plus x cubed. Oops. So there's 2 places it hits, but only one of them has a positive solution. That's the one they want. If I cheat and use Desmos, it looks like 0.724. Right? You with me? So we want to show that Newton's method, right? My x next iteration machine is going to get me 7.24. What do you think is a good starting point? What's a good initial guess? Well, 0.724 better work right away, right? But I could guess 1, or I can guess 0.5 and see how fast I get there. Is that making sense? Good. So first thing we have to do, so this is part C of the project. We have 1 over x equals to 1 plus x cubed. We want to turn that into a function that can get us a 0. So I'm going to say f of x is 1 plus x cubed minus 1 over x. So there's my function, right? I like to make things look a little bit prettier, so I'm going to turn this into a single factored fraction, right? With the numerator factored, the denominator factored. Yes? And so what is it? It's x to the fourth plus x minus 1 all over x. Agreed? Yeah? Just an LCD, right? So that's my function. I need to get, if you look at my x next formula, right? I need to get an x. Well, there it is, an x, because that's what I'm using, right? Just using the variable x instead of x sub 0 or x sub 1. And then I have to subtract the function, which I got, and divide by the derivative, which I don't have yet. So I'm going to get my derivative from here. I'm sorry, from here. Sorry, not there. I'm going to get my derivative from here. I'm not going to use the quotient rule if I don't have to, right? So what do I get for my derivative? Derivative of 1 is 0. Derivative of x cubed is 3x squared. Derivative of negative 1 over x is positive 1 over x to the second. So there's my derivative. Again, I want to make this, clean this up a little bit, right? Maybe I don't have to yet, but let's see what happens if I do. What do I get? I get 3x to the fourth plus 1 over x squared. Yes, you with me? So I want to move into my x next formula now because I have all the pieces. I have an x, I have an f of x, I have an f prime of x, right? I have all the pieces I need. So I get x minus x to the fourth plus x minus 1 all over x divided by 3x to the fourth plus 1 all over x squared. Yeah, so far? Good. Do you see a keep change flip thing about to happen here? Yep. So I want to make this as condensed as I can so it's easier to work in my program, either using Excel or using C++, right? I want to make this thing as tight as I can. So again, saving some energy on the code, the characters, right? So it looks like I get what? X minus x to the fourth plus x minus 1 over x times x squared over 3x to the fourth plus 1. Agreed? One of my x's cancels. Do you see that? And then I'm going to distribute that x in. So I got x to the fifth plus x squared, x to the fifth plus x squared minus x over 3x to the fourth plus 1. I'm going to get a single denominator. Remember, I want a single fraction, completely factored, numerator, denominator. I don't know if I really want this one factored, but LCD, right? So we get what? 3x to the fifth plus x minus x to the fifth minus x squared plus x all over 3x to the fourth plus 1. So it looks like I get 2x to the fifth minus x squared plus 2x all over 3x to the fourth plus 1. This is my iterator. This is the machine that's going to generate for me that solution. What was it? 0.72 something? 724? And I'm going to try and guess. I'm going to guess at 1. I'm going to guess at 0.5 and see what happens. Right? Of course, I can guess at 0.724. Okay, so this piece is the one I'm going to have to remember. So I'm going to take a picture of it because I won't remember. because I'm going to show you how to build the iterator in Excel. Ready? We okay? Any kind of sound, any grunt is fine. You can, some kind of nod or something. Are we okay? No, you're not okay. Because I just did all that algebra and you got to do it on your own. Yes. My first column I'm going to call X. Go figure, right? My second column I'm going to call X next. You do what you want. I'm going to make an initial guess at 1. And I'm putting my iterator here. Notice my first guess is in cell A2. Are you with me there? Column A, row 2. So instead of calling things X, I'm going to use capital A2 to call on the variable X. You with me? So I start with an equal sign anytime I want Excel to generate something for me. And I'm going for my numerator wrapped in parentheses. Yes? Where's my numerator wrapped in parentheses? I need this. Right? So in Excel, I'm typing, right, equals 2 times A2 caret 5 minus A2 caret 2 plus 2 times A2 divided by 3 times A2 to the 4th caret 4 plus 1. Yes, you with me? So instead of X's, I'm using A2. Right? Is that making sense? So I'm calling on that cell where I put my initial guess on. And I'm saying, hey, take that number, put it in, right, to my iterator, to my function. So equals 2 times capital A2, that's my X, right? But raised to the 5th power, yes? Minus A2 raised to the 2nd power plus 2 times A2, there's my 2x from my numerator, divided by, open paren again, wrap multi-terms, right? The entire numerator wrapped, the entire denominator wrapped. 3 times x to the 4th plus 1. Oh, sorry. A2, right? Yeah. Thank you. Boom. Ha! 0.75, pretty close to point, right? Now, I want to take that value and put it into A3. So in A3, I'm typing equals B2. So I'm going to grab that value, that was my next value, and make it my next guess. And now I'm going to fill down. Control D will fill down and fill down. Boom. Huh? Homer? Control D fills down. So it got it in 2 guesses. I guessed 1, and then I got you see the answer repeating? Oh, 3 guesses, right? 3 guesses. Now, what's nice is I can change my starting value. Let's start at 0.5. 3 guesses. 0.7. 2 guesses. So part C pretty much is done for you in the project. Part D is similar, right? Different function. Part E is the tough one. That's the one that's abstract. You're trying to do everything algebraically. Don't give me numbers. And of course, I like, if I ask you for a table, it's nice to make the table look nice, or you can handwrite it. I don't care, right? You can make the table look nice. You can paste it into a Word doc. You can do what you want, but be careful about wasting time. I like to think about the 80-20 rule. 80% of you do is a waste of time. 20% of what you do actually is valuable. You know, if you sit there and you change the margins and you change the fonts, and wasting your time, right? Just bang it out, get it done. Yes. So I think this is probably the easiest way to see it, because that Excel is so tiny as I'm typing it, right? Okay, so looking at you, Brian, you got it? I don't want to rush you there. You got it? So looking at that project, part A, hey, solve for the next X. Part B, write it over with some kind of nicer notation. Part C, right? 6 decimal places is done already, yes? Part D, where I've got a new function where I want the reciprocal of pi. So B is going to be pi, in part D, B is pi. And what do you do on Excel to get pi? Equals pi equals pi to the 15, pi 15. I forget how to get pi. I think it's pi empty parens. There it is, pi empty parens on Excel. Part E, I'm going to talk about error. Do you know how to calculate error? You take the actual number and you subtract off your guess and divide by the actual number, and that will give you percent error, if you remember that from pre-algebra. Actual number minus guess, all divided by actual number, and make it positive, percent error. And you can see it here. It says true value minus the approximate over the true value. That will give you error. So my initial guess was 1. The actual answer was 0.724, right? All subtract that and then divide by 0.724. That's going to give me my error for that first guess. And what you're going to end up doing is showing that your relative error for the first guess, if I square that, I get the relative error for the second guess. So what happens when you square a number? Yeah, okay. Does it get bigger or smaller? Sometimes, if it's bigger than 1, it gets bigger. If it's between 0 and 1, it gets smaller. So you obviously want your error to get smaller, right? In fact, when you finally get the error to 0, or at least get to the limit, right, then you've got your answer. So in part E, it's pretty abstract. All algebraically, figure out a version of the error. No, I can write it. Part E. So the first error, oh, come on. First error is a um, how do I want to write it? Oh, I guess I have to talk about part D first, right? So my function turned out to be pi minus 1 over x. And of course, the answer is for the 0 is 1 over pi, right? Agreed? If I solve that for 0, I get 1 over pi. You agree? Or you could just see 1 divided by 1 over pi is pi. So pi minus pi is 0. Yes, you with me? Anybody? Thank you. So the first error I get is 1 over pi minus x over 1 over pi. Make it look pretty. The second error I get is 1 over pi minus x next over 1 over pi. X next is that formula I get when I generate the iterator. Put that in there and then show that E2, the second error, is the square of the first error, algebraically. So for part D, you got to generate this x next like I did for part C, right? Yes, you with me? And then make that look as pretty as it can. And you will, if you do the algebra, you will show that E1 squared, the first error squared, is the second error, is E2. And that's what this is saying. You see it? Relative, right here in the middle of the page here. The relative error, x sub n, if I take that and square it, I get the next error. Do you see it? Relative error, x sub n plus 1. That's the next error. Again, it reads like a super nerd. Don't be afraid of it. Ask me if you need help. You may get help from anyone on this. You may ask me for help. Right? This is a nice way for you to boost your grade a little bit. Homework is the other way. There's no way any of you should have a homework grade under A, under a 90. Right? So check Blackboard. Get in touch with me. If you handed me homework, I wrote back on it. Homework 3 done, or complete, or fix this last 2 problems, right? I want it to be right. So, but I'll let you do it over. I mean, there's no reason not to do it right. You can do it at home. You can use anything you want. You can, you have the answers. You know you're going to get an answer, right? All right.